Now let us see this, the addition of the effect of the inert gas on the equilibrium at constant volume. See, this reaction is going on in a closed vessel. We have introduced helium as an inert gas and we are not letting this volume to increase. Definitely at constant volume, on addition of inert gas, what will happen is total pressure will increase. That means now P total will be equal to the partial pressure of nitrogen, partial pressure to the sum of the partial pressure of hydrogen, partial pressure of ammonia, and now we have helium also. So this PT will increase because earlier we were having only these three, now we have this fourth gas also. But what is important to note is, but partial pressures of nitrogen, hydrogen and ammonia remains unchanged. Because what does it mean? These three partial pressures doesn't get changed. They don't have any change in their values. Because you have introduced a gas, keeping the volume constant, total pressure is increasing, but the partial pressures of nitrogen, hydrogen and of ammonia are not changed. They have not changed. Since they have not changed, due to this reason, what will happen is the partial pressures are same. So therefore, Kp will remain same. Once the Kp is same, it means what? The equilibrium has no effect of addition of an inert gas at constant volume. Therefore, no effect on equilibrium. This is what is the main is. So whenever an inert gas is added to a reaction mixture which is already at a state of an equilibrium in a closed vessel at constant volume, the equilibrium doesn't get affected because only the total pressure increases, but the partial pressures of the gases which are involved in the reaction remains always the same as it has been earlier. So the Kp remains same, therefore no effect. So what simply we can write is that the addition of an inert gas at constant volume has no effect on equilibrium. Now let us take the addition of inert gas at constant pressure. It means what? This reaction is going on in a vessel. We have introduced a helium into the reaction mixture which is involving the reaction of a nitrogen, hydrogen with ammonia, and the system was at equilibrium. We have introduced helium. Now we are keeping the pressure constant. Now since pressure is kept constant, volume of the reaction mixture will increase. Why it will increase? Because you have introduced another gas. Therefore, volume V increases. Now we know the partial pressures like of nitrogen will be number of moles of nitrogen RT by V. So this is how all the partial pressures of these gases are inversely proportional to the volume. It means what? These P are inversely proportional to their volume. So if this volume is decreased, the partial pressure will, the volume is increased, these partial pressures will decrease. So therefore, the partial pressure of gases will decrease. Once these partial pressures decreases, it means we are moving the system towards the side, or it will on its own will move towards the side which contains what? More number of moles of the gaseous substances. Therefore, equilibrium shifts to the side having more number of moles of gaseous substances, because you are decreasing the volume is increasing, pressure is getting decreased. Since volume is increasing, the system will be favoring to the side which contains more number of moles of the gaseous substances. So the system will move toward the side which contains more number of moles of gaseous substances. So if in this case, like in this reaction, if we introduce helium at constant pressure, since the reactant side contains 4 number of moles and the product side contains only 2 moles, the reaction will move back. So we can't add any inert gas into this system. So it's very simple that whenever an inert gas is added at constant pressure, the equilibrium shifts to the side which contains lesser number of moles of gaseous substances.